Okay, let's continue with number 7. This is differential equation, multiple choice. A cup of coffee at temperature 108 degrees Fahrenheit is placed on the table in the room at 68 degrees Fahrenheit. The temperature at the time, differential equation is dy dt equals negative 0.11 y minus 68. Order pair 0. 180 is the initial temperature. After 10 minutes, find the temperature of the coffee. So we have the equation provided for us. I'm going to separate variables. So if I think of this as this expression divided by 1, I can cross multiply and I get 1 times dy is equal to negative 0.11 y minus 68 dt. Okay. Once I have cross multiplied, I see that there's still something out of place, and that's the y minus 68. Take that y minus 68, divide it over to the left side, and now we see that this is going to be a U-substitution problem, possibly leading us into natural log. So we'll let the u value be y minus 68. Derivative is just 1, so dy equals du. We make our substitution. Cleans up to be just 1 over u du. The right side, I can push that coefficient out in front, and really I'm just taking an integral of 1 dt. So integral of 1 dt becomes just 1t. So let me finish this off here. Okay. Okay, so the antiderivative of 1 becomes 1t with the coefficient attached to it, plus c shows up. And now, once I'm here, then I'm going to try to bring everything back in terms of y. So u becomes natural log, becomes y minus 68. So now we're stuck with this form, but that plus c is there. I'm going to wait to solve for c. We have the our general antiderivative. So now I'm going to raise both sides with base e. This cleans up to be just absolute value of y minus 68. The right side becomes e to the negative 0.11t times e to the c, right? This is an exponent, right? If we want to bring that down, it becomes e to the c. Bring that e to the c as a coefficient, bring that out in front, drop the absolute value, and then solve for y. Okay, so now once we solve for y, we can plug in order pair 0, 180 to solve for c. So 0 plugs in for t, 180 plugs in for y. E to the 0 is just 1. Subtract 68, we get 112. Replace 112 in for the c, and then we have our specific equation. But then there's one more thing we need to do, and that is finding the temperature at 10 minutes. So we know that this is our equation that will help us find any temperature at any given time. So if I plug 10 in for t, use the calculator to reduce that to be a numeric value, so 105 degrees Fahrenheit. All right, number 8, solutions of the differential equation y dy equals x dx are of the forms. So the nice thing is this is already separated. We already have full separation of variables. So let's go ahead and find the antiderivative. Power rule on both sides. Y dy becomes y squared over 2. X becomes x squared over 2 plus c. So we're getting closer to matching one of these forms. I'm going to multiply everything through by 2 so I can get that fractional 2 to go away. So distribute the 2 through. I get y squared equals x squared plus c. And again, 2 times c, the 2 just absorbs into that c, so we'll just leave it as plus c. And if I kind of rearrange this to match one of these forms, looks like x squared and y squared are going to have different signs. So I can make it x squared minus y squared equals negative c. And negative c can be thought of as just plus c because c can take positive and negative values. So these are the same things, but this form just matches better with A. The solution curve y prime equals y that passes through order pair 2, 3 is. So let's make this a little bit more descriptive here. Y prime is the same thing as dy over dx. So rewrite it as dy over dx. Cross multiply. I get y dx equals 1 dy. Take the antiderivative. Well, not yet, sorry. dy is equal to y dx. This is not quite separation of variables is not complete. So we're going to divide both sides by y, bring the y over to the left side. And now we can do natural log for this form, this setup here on the left. On the right side, it's just 1 dx, so integral 1 dx becomes x. So we get natural log of y is equal to x plus c. We can raise both sides, exponentiate both sides, base e. Once we do that, left side cleans up. We get e to the x times e to the c. This cleans up to be just ce to the x. 2 plugs in for x, 3 plugs in for y. We get 3 is equal to ce squared. Divide both sides by e squared. 3 over e squared is equal to 0.406. So now we can replace 0.406 in place of the c. And now we get y is equal to 0.406 e to the x. Right, number 10, according to Newton's law of cooling, the temperature of an object decreases at a rate proportional to the difference. So proportionality means that this is going to take on the form of y is equal to kx. Everything should be in the numerator. Okay, so suppose the corpse at temperature 32 degrees Celsius arrives at a mortuary where the temperature is kept at 10 degrees Celsius. Then the differential equation satisfied by the temperature T, T hours later is, so we know we're trying to create a differential equation, so it's going to be dt over dt. We know that we have k involved because we're finding proportionality here. And then the difference surrounding temperature, so T minus 10, or T minus 10. And also we know that the temperature is decreasing, so the negative is going to be out in front here. So we got the constant proportionality, we got that temperature 32 minus 10, and that T represents that initial temperature. We know this T is continually changing, right? It's going to keep decreasing here. And so that negative will take care of that. So answer choice A. Okay, so 11, we're going back to the equation that we found from number 10. We have a couple of temperatures here. We know at time t equals 0, temperature is 32 degrees. At 1 hour later, it's going to be 27 degrees, right? Keeps dropping. So based off of this, can we create an equation based off of these two information? So a couple of things we need to solve. We need to solve for k. We need to solve for c. But first, I'm going to separate the variables. So bring the dt over to the right side. I want the t's on the left, or uppercase t's on the left, and lowercase t on the right. So divide both sides by uppercase t minus 10. We know that we have full separation of variables. Uppercase t on the left, everything else on the right, including constants like this constant of proportionality. This is set up like a U-substitution problem with our u value being the denominator. So u is equal to uppercase t minus 10. du dt equals 1. dt equals du. Left side cleans up to be just 1 over u du. The right side, negative k. Integral of 1 becomes just t. So this becomes negative kt plus c. Okay. We go ahead and replace the u back in terms of t. And now we have our general equation, but let's go ahead and solve for t. Get that natural log out of the way, and the way we do that is we exponentiate both sides, base e. So this cleans up to be just uppercase t minus 10. The right side becomes ce to the negative kt. Bring that 10 over to the right side, so now we have our general equation. We have a couple of order pairs that will help us solve for our missing values, missing variables. So plug 0 in for lowercase t, and 32 in for uppercase t. So lowercase t is time, uppercase t is temperature. So 32 is equal to ce to the negative k times 0 plus 10. And so that's going to clean up to be just c plus 10 equals 32. Subtract 10 from both sides, we get c equals 22. replaced our c with 22. Now we can solve for k. So 1, let's use the second order pair that we have. 1 plugs in for t, lowercase t, for time. 27 plugs in for uppercase t, temperature. 27 is equal to 22 e to the negative k plus 10. Subtract 10 from both sides, divide both sides by 22. Natural log both sides. Solve for k. K is equal to 0.2578. So now we can put k in our general equation. So we get CE to the negative 0.258 t plus 10. Okay, so that's answer choice C.